Unit 5, Lesson 8. This lesson works with position, speed, and direction. So number 1, working with distance, rate, and time. It says an airplane moves at a constant speed of 120 miles per hour for 3 hours. How far does it go? Okay, so I know if it's moving at 120 miles per hour and it travels for 3 hours, then I can multiply 120 times 3, so that's 360 miles. Number 2, a train moves at a constant speed and travels 6 miles in 4 minutes. What is its speed in miles per minute? So we do not know the miles per minute, but we know how far it traveled and we know how long it traveled. So our speed times our time gives us the miles traveled. So in order to determine speed, you would divide 6 divided by 4, and that gives you 1.5 miles per minute. Number 3, a car moves at a constant speed of 50 miles per hour. How long does it take the car to travel 200 miles? Okay, so we know the speed this time. We don't know our time, but we know it travels 200 miles. So again, we can just divide. So 200 divided by 50 equals 4 hours. (8.2) Going left and going right. So you should see a number line. It says, after each move, record your location in the table. Then write an expression to represent the ending position that uses the starting position, the speed, and the time. So the number line is just there for a reference for you. So on the first one, it says that it starts at 0. So starting here, I'm moving to the right at 5 units per second. So every second I travel 5 units. And I do this for 3 seconds. So there's 1 second, 2 seconds, 3 seconds. And you see that we finish at an ending position of positive 15. So I had to move 5 units 3 times. And then you add that to your starting position of 0. So on the next one, starting at 0, we're moving to the left 4 units per second for 6 seconds. So what would the ending position be? Okay, so every second we travel 4 meters going left, or 4 units, I'm sorry, for 6 seconds. So there's 1, 2, 3, 4, 5, 6. So we finish at negative 24. So our expression would be 0 plus negative 4, because I'm traveling to the left, times 6. Or you could also write that as 0 minus 4 times 6. Okay, so if you travel to the right, starting at 0, with a speed of 2 units per second for 8 seconds, what would be your ending position? So that would be positive 16. And your expression would be 0 plus 2 times 8. Next row, traveling right, 6 units per second for 2 seconds. So your ending position would be positive 12. Expression would be 0 plus 6 times 2. Okay, last one. So we're moving left now at 1.1 units per second for 5 seconds. negative 5.5 would be our ending position. So 0 minus 1.1 times 5. Number 2 says, how can you see the direction? So our directions, how can you see that direction of movement in the expression? So the plus or the minus. So if you see a positive or addition, that means I'm moving to the right. If I see the negative or the subtraction sign, that means I'm moving to the left. Number 3, using a starting position as P, a speed S, and a time T, write 2 expressions for the ending position. One expression should show the result of moving right, and one should show the result of moving left. So when we moved to the right, we had our starting position, and we had to add that to our speed multiplied by our time. When we moved left, we had our starting position, and then we subtracted our speed multiplied by our time. So this equation is for moving right, and this one's for moving left. (8.3) A traffic safety engineer was studying travel patterns along a highway. She set up a camera and recorded the speed and direction of cars and trucks that passed by the camera. So positions to the east of the camera are positive, and positions to the west are considered negative. So if a vehicle is traveling east, it has a positive velocity. If it's traveling to the west, then it has a negative velocity. So velocity is just your speed with a direction added. So if I say you're traveling 10 miles per hour, that's just your speed. But if I say you're traveling east at 10 miles per hour, that's your velocity. So when our velocity is positive 25 meters per second, and 10 seconds have passed after passing the camera, then my car has an ending position of positive 250 meters. So our equation was 25 times 10. So on the next one, negative 20 meters per second. So that tells me I'm traveling to the west at 20 meters per second. And I travel that direction for 30 seconds. So if I'm traveling 20 meters west each second for 30 seconds, then my ending position would be negative 600 meters. So that would give me negative 20 times 30 equals negative 600. Okay, here we have a positive number. So it means I'm traveling east at 32 meters per second. And 40 seconds have passed after I passed the camera. So I know my equation would be 32 times 40. So what is my ending position? 1,280 meters. Okay, negative 35 meters per second on my velocity, which means I'm traveling which direction? West, for 20 seconds. So my ending position is what? Negative 700. So I have negative 35 times 20, which would put me at negative 700 meters. And last one. So I know I'm going to be traveling 28 meters per second to the east, but no time has passed after passing the camera yet. So what is my ending position? I'm still at 0. If no time has passed, that means I haven't passed the camera yet. I'm just there at that exact moment. So my equation would be 28 times 0 equals 0. Number 2 says if a car is traveling east when it passes the camera, will its position be positive or negative 60 seconds after it passes the camera? So if it's traveling east, it's going to be positive. So if we multiply two positive numbers, is the result positive or negative? So that means a positive number times a positive number. That would give me a positive 4. Number 3, if a car is traveling west when it passes the camera, will its position be positive or negative 60 seconds after it passes the camera? It will be at a negative position because it's traveling west. So it says if we multiply a negative and a positive number, is the result positive or negative? So if I had negative 2 times 2, well, 2 times 2 is 4. I know that. But if I'm traveling in a negative direction, then I'm going to be negative. Okay, so it says we can use sign numbers to represent the position of an object along a line. So if our reference point is 0, that means any position to the right of 0 is going to be a positive, and any position to the left is going to be negative. So again, if we combine speed with direction, it's called velocity. So if you're moving 5 meters per second to the right, your velocity would be positive 5 meters per second. If you were moving 5 meters per second to the left, your velocity would be negative 5 meters per second. So a positive times a positive is going to be a positive. Negative times positive will be negative. And on multiplication, you should know that order does not matter. So if I had a positive times a negative, well, it's still negative 5 times 10. Order doesn't matter, so my answer is still negative.